This is where we left off in the previous session. To find the ratio n1 to n2, we don't really have to perform this long procedure. Just this was enough to get the ratio. But how did we write this directly? That's what we will understand in this video. By now, we should be comfortable with the weighted average formula. It equals A1N1 plus A2N2 divided by N1 plus N2. If you haven't watched the weighted average examples, I think you should. It will help you breeze through the rest of this topic. So what we need is the ratio N1 to N2. To get that, let's transpose the denominator to the left. We get this. Now, as we want the ratio N1 to N2, let's keep N1 on the left and N2 on the right. We transpose A1N1 to the left and ARN2 to the right and get this. The term N1 is common to both the terms on the left and the term N2 is common to both the terms on the right. Taking the common factors out, we get this. And to get the ratio, we transpose N2 to the left and this to the right. That gives us the ratio N1 to N2. It equals A2 minus AR divided by AR minus A1. Now you know how we got the ratio quickly. It's simply A2 minus AR divided by AR minus A1. So if we have A1, A2 and AR, we just use this formula to get the ratio N1 to N2. Now let's apply this to the problem we just saw. There are two divisions in class 8, divisions A and B. The average weights of the students are 50 and 60 kilograms in divisions A and B respectively. And we are given the average weight of all the students in class 8 as 58 kilograms. Now with this information, we are asked for the ratio of number of students in class 8A to the number of students in class 8B. Applying this formula, we get A2 minus AR as 60 minus 58 and AR minus A1 as 58 minus 50. And we get the ratio as 2 over 8 or 1 over 4. But this might be a little confusing to remember. So we look at an amazing way to understand this formula. So here we have A1, A2 and AR. We write it like this in an upside down triangular fashion. We write 60 minus 58 here, 60 minus 58. And we write 58 minus 50 here, 58 minus 50. This is 2 and this is 8. This is the ratio we are looking for, 2 to 8. You will soon realize that this is much easier as compared to remembering this. And don't forget, this does not mean that N1 is 2 and N2 is 8. This just gives us the ratio N1 to N2. And though we are subtracting 58 from 60, this corresponds to 8A. And even though we are subtracting 50 from 58, this corresponds to 8B. If you are seeing this for the first time, there is a very high chance that you find it confusing. That's quite common, don't worry. We just need to know two things. First, both operations are done diagonally. Second, we always write greater minus smaller in each case. 60 minus 58 and 58 minus 50. These are the only things you need to know once you have written the given data. This is one of the fastest techniques that will give us the ratio N1 to N2. And remember, the overall average will always be between the two given averages. That's obvious as the weighted average cannot be beyond this range. Let's quickly try one example with this technique. This is the data we have been given, and we need to find the ratio of the number of students in 7A to the number of students in 7B. We have the average heights of the students in 7A and 7B, and we have the overall average heights of all students of class 7 as 175 centimeters. How do we find this ratio? As we need to find this ratio, we use the approach we just saw. The two averages are 160 and 180, and the resultant average is 175 centimeters. Do you remember the two things we had to keep in mind? First, diagonals, and second, greater minus smaller. In this diagonal, 180 minus 175 will give us 5. And in this diagonal, 175 minus 160 will give us 15. And never forget that this is a ratio. This ratio is also equal to 1 to 3. The ratio is 1 over 3. That's how simple it is to find the ratio when these three parameters are given. And this technique has been given a fancy name. It's called alligation. Yes, this style is referred to as alligation. Remember, diagonal and greater minus smaller. Wait, hold on. We have the weighted average formula. It says that the weighted average is equal to A1N1 plus A2N2 divided by N1 plus N2. And then we have this alligation concept. When should we use the weighted average formula and when should we use the alligation technique? We see that in the next session. This was the previous example we had seen based on alligation. We had to find the ratio here and we used alligation. Same ratio can also be found using the weighted average formula. So when should we use this formula and when should we use alligation? That's what we will understand in this video. So by now, we are very well versed with the different parameters present in a problem. The two averages A1 and A2, the resultant weighted average, and the ratio of the weights of the averages. These are the four important parameters in any weighted average, alligation, or mixture problem. We will generally be given 3 and asked to find the fourth. But the important question is, when do we use the weighted average formula and when do we use the alligation formula? There is a simple rule of thumb you need to know. Whenever we need to find the weighted or resultant average, use the weighted average formula. It says that the weighted average is equal to A1N1 plus A2N2 divided by N1 plus N2. Whenever we need to find AR, use this formula. And whenever we need to find the ratio of the weights, we use the alligation formula. A1 and A2 will be given, AR also will be given, and we apply the two rules, diagonal and greater minus smaller. Assuming A1 is smaller than A2, we will write A2 minus AR here and AR minus A1 here. And don't forget the most important thing. This is a ratio of the weights of A1 and A2 respectively. Let me repeat. Find AR, use the weighted average formula, and find the ratio of weights, use the alligation formula. But why? Why not use the alligation formula always? Let's take an example to understand how we derive this rule of thumb. This video is going to be a bit lengthy, but it's one of the most important ones for this topic of weighted averages and alligation. So hang in there. In this example, we are told that 10 kilograms of rice A was sold at 40 rupees per kilogram and 15 kilograms of rice B was sold at 50 rupees per kilogram. What will be the average selling price of both these quantities together? Take a moment and go through the problem well. Now, out of the four important parameters, what all are we given here? That's the first thing we need to analyze. Here, the selling price of rice A will be A1 and the selling price of rice B will be A2. Remember, the problem may not literally mention that these two are averages. We need to understand that they are nothing but averages. Average is nothing but the total sum divided equally among all samples. Here the total cost is divided equally to every kilo. So we have 40 and 50 as the two averages, A1 and A2. And we have been asked for the average selling price of both these quantities together. So we have been asked to find the resultant average. And these two will be their respective weights. They are 10 and 15. We need to find AR. We just saw how alligation works. We have A2 minus AR here and AR minus A1 here. So can we implement this logic here? Let's try. 50 minus what gives us 10? It will be 40. But 40 minus 40 is 0, not 15. Where are we going wrong? I repeat, this is the most important thing in alligation. This is a ratio. this will not give us the actual weights. But here, 10 and 15 are the actual weights. The ratio can be anything. It can be 2 to 3 or 4 to 6 or 6 to 9. We can't guess. And that is why it is difficult to find AR here. Whenever AR is asked, we should avoid using alligation. So let's use the weighted average formula. It equals A1N1 plus A2N2 divided by N1 plus N2. Applying that formula will give us this. Wait, before you go ahead with the calculations, is there a faster way to apply this formula? All we need is the ratio of the weights. The ratio 10 to 15 is the same as 2 to 3. We can use 2 and 3 instead of 10 and 15. So we can also write AR like this. Yes, this might just save you around 5 seconds of your time, but trust me, 5 seconds is a lot of time for any test prep exams. Solving this will give us the answer as 46 rupees per kilo. That's the average selling price if both these quantities are sold together. So never use alligation when the weighted average is asked. Now let us quickly look at another example. Rice A is sold at 40 rupees per kilogram and rice B is sold at 50 rupees per kilogram. This time, we are given the resultant selling price by selling both rice A and rice B together. And we need to find the ratio of the quantities of rice A and rice B sold. Here we are asked for the ratio of quantities. By the rule of thumb, we should use the alligation concept here. But why? Let's say we use the weighted average formula to solve for the ratio of weights. This is what we get after substituting the values. This is the resultant average. 40 and 50 are A1 and A2, and the quantities are QA and QB. With this, it is possible to find the ratio, but it's very time-consuming. Let's see how alligation makes our life simple. A1 and A2 are 40 and 50, and the average selling price is given to us as 48 rupees per kilogram. Now we are ready to find the ratio. Diagonal and greater minus smaller. Here we will have 50 minus 48, and on the right we will have 48 minus 40. And this is a ratio. This is equal to 2 and this is equal to 8. This is the ratio. It can be reduced to 1 to 4. This is the ratio in which rice A and rice B need to be sold if the average selling price is 48 rupees per kilogram. This does not give us the quantities. It just gives us the ratio. You will get the same ratio if you solve it using the formula, but it won't be this fast. So now you know when you have to use the formula and when the alligation concept. Don't worry, we will cover many more examples in the coming sessions. A solution having 40% water is mixed with a solution having an undisclosed amount of water such that the resultant solution has 50% water. Two solutions are mixed here. One solution has 40% water and the other has X% water. We shouldn't really care about what the rest of the solution is. In all cases, we just look at the water percentage. Now both these solutions are mixed and the resultant solution has 50% water. We have also been told about the ratio of the weights of the two solutions that are mixed. It's 3 to 5. We have been asked to find X. What percentage of the second solution has water? Now the moment we see this problem, we should realize that it's a weighted average problem. Two quantities are mixed to get a resultant quantity. Do you remember the rule of thumb we had seen for weighted average problems? If we have been asked for the weighted or the resultant average, we use the weighted average formula. And if we've been asked to find the ratio of the two weights, we use the alligation concept. This was our rule of thumb. So what do we use here? Here, we have been given the percentage of water in the resultant solution. So AR has been given to us. We also have the ratio of the weights of the two solutions. So N1 to N2 is also given. So which concept do we apply to this problem? Should we use the weighted average formula or the alligation concept? As we're not sure, let's try both. The weighted average formula tells us that the resultant average is equal to A1N1 plus A2N2 divided by N1 plus N2. As AR, A1 and A2 are all given in percentage terms with respect to water, we can substitute those three values here. The resultant solution has 50% water, and we substitute the rest of the values to get this: 40% water and X% water. The ratio is 3 to 5. After this step, let's not waste time writing 50% as 50 over 100, 40% as 40 over 100, and so on. As all are in percent terms, X will also be in percent terms. With this, we can solve for the value of X. So the weighted average formula works. But let's see if the alligation concept works here. 40 and X are A1 and A2, and the water percentage in the resultant solution is 50%. Now clearly X has to be greater than 50, because 50 lies between 40 and X. Diagonal and greater minus smaller. We get X minus 50 here, and we get 50 minus 40 here. And this is a ratio. So the ratio is X minus 50 to 10, and this ratio is given to us as 3 to 5. As 5 times 2 is 10, even 3 times 2 will equal X minus 50. X minus 50 will be equal to 6, so X will be equal to 56. The second solution has 56% water. You would get the same answer even if you use the formula. Now, if you ask me, I would say that the alligation technique is faster. With enough practice, using the alligation technique becomes very easy. So if we are given the resultant average and the ratio and asked to find one of these two quantities, alligation is still a better approach. There is one thing you need to be careful about when you apply alligation. These three things here should be with respect to the same thing. Here all three are with respect to water. 40% water, X% water, and 50% water. Even if one of them is with respect to anything else, alligation will not work. This problem is really tricky. How many grams of gold costing 2,500 rupees per gram should a jeweler add to a bag with 30 grams of platinum costing 2,100 rupees per gram? And this should be done in such a way that he makes a profit of 20% on selling both together at 2,700 rupees per gram. Pause the video and go through this problem again. Clearly, there are two things we are talking about here: gold and platinum. The parameters given to us as the cost price of each. Gold costs 2,500 rupees per gram and platinum costs 2,100 rupees per gram. We have the resultant average too. Both of them together can be sold at 2,700 rupees per gram. This is what is given to us. With this, we will get the ratio of the weights in which they are taken together. And once we get this ratio, how will we get to the answer? We know that 30 grams of platinum exists in the bag. And based on proportion, we can find the weight of gold that needs to be added. As simple as that. So did you get the ratio? Maybe you did, and I can tell you that it's incorrect for sure. Why am I saying that? There are a couple of reasons. First, pure logic. The resultant average has to be between these two averages. 2,700 does not lie between 2,500 and 2,100. That's when we should realize that what we are doing is incorrect. Second, all the parameters are not with respect to the same thing. 2,500 is the cost price of gold and 2,100 is the cost price of platinum. And what about 2,700? Is it the overall cost price? Read the problem well. They have told us about selling both together at 2,700. It is the selling price, not the cost price. Remember, alligation will not work if all quantities are not with respect to the same thing. So what we need is the resultant cost price. So read this last line again. The jeweler makes a profit of 20% on selling both together. It tells us that the selling price will be 1.2 times the cost price. This tells us that there is a 20% profit. We have been given selling price as 2,700. Hence, cost price will equal 2,700 over 1.2. That equals 2,250 rupees. This is the overall cost price of both things together. Now we have all the data we need. So let's use the alligation concept for gold and platinum. Why are we using the alligation concept here? It's because the resultant average is given. If the resultant or the weighted average is given, alligation is always faster. The cost price of gold is 2,500, that of platinum is 2,100, and the resultant cost price is 2,250. Notice that we have divided each of the three parameters by 100. We did this to make our calculation simpler. Will the ratio change if we do this? Not at all. If we had not divided these three by 100, it would have got cancelled anyway after simplifying this ratio. So we use the diagonal and the larger minus smaller concept. 22.5 minus 21 is 1.5 and 25 minus 22.5 is 2.5. And this is a ratio. This is the same as 15 to 25 or 3 to 5. This is the ratio of gold to platinum in the jeweller's bag. And we are told that the bag contains 30 grams of platinum. 5 times 6 is 30 and 3 times 6 will be 18 grams. It's nothing but simple proportion. 3 over 5 will equal what over 30? It'll be 18. This is what the bag will contain. 18 grams of gold and 30 grams of platinum. That is when the jeweler will make a profit of 20% on the sale. There are a few things we should have learned here. First, don't just blindly copy the data. You should know what you're doing. Second, for alligation, all the parameters must be with respect to the same thing. Here, we made sure that all are with respect to the price. And lastly, A1, A2 and AR can be divided by the same number to make our calculations easier. This ratio will not change if all three are divided by the same number. I strongly recommend that you go through this video again as it helps us with various concepts. I borrow 62,000 rupees at 6% simple interest and another 186,000 rupees at 5% simple interest. What is the overall interest rate? We are borrowing different amounts at different interest rates. And we need to find the overall interest rate when both these cases are considered together. Though not specified directly, we can see that it is a weighted average problem. These are the two averages and these are their respective weights. Another thing you should quickly notice is that I have borrowed more money at 5% than what I have borrowed at 6%. It means that the overall interest rate will be closer to 5% and not 6%. So we have been given that A1 is 6% and A2 is 5%. These are the two averages. And N1 will be 62,000 and N2 will be 186,000. These are the respective weights of the averages. And we need to find the resultant average. And now we come to the important question. Do we use the weighted average formula here or do we use alligation? Do you remember the thumb rule? If we need to find AR, we use the weighted average formula. And if we want to find the ratio N1 to N2, we use alligation. As we need to find AR here, we use the weighted average formula. A1 N1 plus A2 N2 over N1 plus N2. Pause the video and find the overall interest rate here. Okay, if you tried answering it, I'm sure most of you would have got the correct answer. But I repeat, in your test prep exams, what matters most is how quickly you get the answer. There are two common mistakes that students make here. First, they substitute the values and write the percentages in fraction form. They write 5% as 5 over 100 and 6% as 6 over 100. This is not necessary at all. If we keep both as percent, the overall average we get will also be in percent form, which is exactly what we want. And the second common error that students make is substituting the values of N1 and N2 as is. Remember, the exam is not testing your computational abilities. They are just testing your ability to find the answer in the most quickest and most logical way. None of these ways are wrong, but they are just time-consuming. Here, the ratio N1 to N2 should be enough. It will equal this. Can this be reduced or simplified further? Yes, the zeros can be cancelled, and 62 times 3 is 186. This ratio can be written as 1 over 3 in the simplest form. And I'm sure you know that substituting 1 and 3 in place of N1 and N2 will give us the same answer. So we write A1N1 as 6 times 1 and A2N2 as 5 times 3 and N1 plus N2 as 1 plus 3. 6 plus 15 over 4 is 21 over 4, which equals 5.25%. This is the overall interest rate that would apply to us. It is closer to 5% as we have borrowed more money at 5%. Starting with the next video, we will be applying this concept to mixtures.